In this video, I introduce a listen-attend spell model for speech recognition. Listen-attend spell model transcribes audio sequence signal into a word sequence, one character at a time, which learns all the components of a speech recognition model jointly. The LAS model produces character sequences without making any independent assumption in the label sequence and doesn't rely on hidden Markov models. The listener is a pyramidal LSTM that converts low-level speech signals into high-level features. The speller is a LSTM that converts the high-level features into output utterances by specifying a probability distribution over sequences of characters using the attention mechanism. The listener and the speller are trained jointly. This is a listener and this is a speller. Listener use low-level speech signals as an input, and the output is high-level features. That is used as an input to the speller. Here is the attention model. LAS uses acoustic features as input X and emits characters Y as output. Suppose that X is the input sequence of a field bank spectral features. Y is output sequence of characters. SOS and EOS are the start of a sentence talking and the end of a sentence tokens respectively. Each character output YI is conditioned on the previous output characters Y from 1 to I-1 and the input signal X. So it's equal to product of conditional probability of yi given X and Y1 to yi-1 as shown here. The listener converts the original signal X into the high-level representation H, whereas the speller uses H to produce a probability distribution over character sequences. So we calculate H from X through listener. And then now we calculate the probability of Y given X from attention and spell modules. The listener uses pyramid bidirectional LSTM model to reduce the length from T to U. The output at each time I from the layer G is computed as here, as shown here. Calculate this H using this H and these two H's. Pyramid bidirectional LSTM model concatenates 3 layers of bidirectional LSTMs to reduce the time resolution 4 times. Here is 4, this output 1, which allows the tangent model to extract the relevant information from a small number of time steps. Output yi is a function of the decoder state Si and context Ci, which are computed Ci from Si and H, and Si from Si-1, yi-1, and Ci-1, as shown here. So we get the conditional probability of yi given X and Y1 to yi-1 here. Where the context Ci is computed from here. So this is E IU and this A alpha IU. Where phi and psi are multi-layer perceptron networks. The listener and the speller are trained jointly in end-to-end fashion to maximum sum of log p, where this y star 1 to I minus 1 is the ground truth of the previous characters. During inference, the goal is to find the most likely character sequence for the given input here. Decoding is performed with the left to right bin search algorithm. Start with SOS token. We maintain a set of partial hypotheses. At each time step, each partial hypothesis in the bin is extended with every possible character, and the only most likely bins are kept. When the EOS token is encountered, it's removed from the bin and added to set of complete hypotheses. We restore the bins with the language model, and then now finally we get the probability of y given x using sum of two terms, where lambda is the weight of the language model and YC is a normalization number. For more details, please check with these references. Thank you.